Electron beam diffraction off of crystal. Consider a beam of electrons of uniform energy 100 eV falls in the z direction on a crystal with a cubic lattice of lattice spacing 5a, e.g. 5 angstroms or 5 times 10 to the minus 10 power meters. Aligned with the x, y, and z axes, write a wave function in the form of a plane wave that can be used to represent the beam of electrons. Ignore normalization, assuming that most of the beam reflected from the crystal is reflected by the plane of atoms on the surface. What will be the angle from the normal to the first maximum of the diffraction pattern of the reflected electrons? Answer: A. Start with a general plane wave moving in the z direction.
See the equation. The de Broglie wavelength of an electron of electric energy of eV is given by. See the next equation. With E equals 100 in units of eV. Thus K equals 2 pi over lambda equals 5.11 times 10 to the 8th power times Cn to the minus 1 power with W equals E over italic H over 2 pi. B. Phase difference delta equals 5 normal A sine theta equals n lambda, so for n equals 1 at the first maximum, theta equals the inverse sine of open paren lambda over 5a close paren. Thus, see the equation. Thus the angle to the first maximum will be theta equals 14.2 degrees.